Hello. Uh, I got good and bad news, Jensen. Bad news. I won't be streaming soon for like a month or a bit longer than that. Good news is I'm planning to fly off on the 26th. And my flight training will start on the 27th. But remember, it doesn't mean anything. It is wasted effort and money until I get into a cadet program. If I get into the cadet program due to this, it would be worth every cent, of course. But if I end up not getting into the cadet program despite this, then it's a huge waste of time and money. But I think I have to do it. No choice. Yes, sir. Why is the plant just in the tree? Yeah, there's an evasion program. I don't know if I answered that already. Mud or sand. High thrust. High density. Low thrust. High weight. High friction forces. High aerodynamic drag. Upslope. Low density. That's also quite tight, man. It probably will at some point. I think that's planned, right? No, I don't understand this part. Because the standard atmosphere is 15 degrees at 0 feet. I don't know why they say it's 3,500 here. This is just so wrong. This is not true at all. I don't know why they're just saying that. I think what they mean is that the altitude, or just the height of the airport is 3,500. Because in international standard atmosphere, it is 0 degree. 15 is 0 feet. You can literally Google this. What is the altitude at ISA 15 degrees? Alright, ISA. That's not my question. What is the altitude at standard atmospheric pressure and temperature? Yeah, 0 meters. And then you read here, ISA at 3,500 would be plus 15. It's so wrong. This should be 7. Should be 8. Because the higher you go up, the more, or the less it is. And it is 8. So the way they worded this is wrong. The result is correct, but the way they worded is wrong. And no, 12 is not 4 degrees above ISA. 12 is 3 degrees under ISA. Huh? I don't understand at all what they're saying. Here it says 15 degrees, bro. And here it says ISA is 12 degrees. Or 8 degrees or whatever. No! Dude, I read this in 4 different textbooks. Even their own textbook said this. This textbook said the same thing. They just worded it completely wrongly, somehow. Temperature plus 10. First, the pressure altitude is 20 below. That would be 600 feet. Minus 600 feet. Plus 600 feet. Oh, crap. Accidentally, huh? Yeah, of course. Bro, how confusing is this? Alright, so I have 5,000. Intersect at a 10-degree line. That's not what you did. The 10-degree line is here, no? I'll draw a horizontal line across. Meet the 10-degree line. So... Okay, I'm just gonna... Alright. So... Start at 5,000. And draw down to 10 degrees. Line. I zoom in a bit. 5,000. What does it say? Draw a horizontal line across to intersect the plus 10 degree line. A horizontal line across. Okay, so here. Roughly here. Boom. Alright. I'm gonna draw a vertical line up to the Toda again. Takeoff distance available. Takeoff distance available. 900. Okay. So straight up. No. 900. Straight up. 900. Okay. Draw a horizontal line to reference the line. The reference line follow the guidelines down to the particular surface line. Short, wet grass. Where this line intercepts the climb weight limit line from below. Where this line intercepts the climb limit line from below. I'm so confused. This one? YouTube, that's not.
Hello everyone, in today's video we're going to be continuing our discussion on intermittent.
No.
This is the level dry run with we don't even need to catch.
have a temperature of 24 degrees Celsius, we will have to interpolate between the values. Therefore, for our final ground roll, by doing simple math and multiplying 14 times 10 and dividing it by 9, we can figure out the exact value to subtract from our takeoff distance, which ended up being 15.6%. Therefore, for our final
Dude, why do all these look so different from mine? Yeah, I'm so confused, man. Dude, I'm getting actually triggered. Like, why can't textbooks be fucking good? What is this? It says plus 10 degree line. That one is here. Why did they put it here? I'm getting so annoyed, man. What do they want from me? Like, how are you not explaining anything? It's literally the exact same chart here. But I also don't explain shit. Enter the shade temperature scale at plus 16. Yeah? Move vertically up to hit the force and height line. Why do they have different procedures? Anyway, yeah. Hit the reference line for surface. I don't know what he's saying, dude. Oh, why is there no explanation? I'm about to vomit, man. I'm literally about to vomit. This is so poorly explained. Holy shit. It's terrible, man.
Hey guys.
Oh.
So the first thing you're going to do is you need to...
Why does mine look so different?
come in at where the temperature is. So you're going to find the temperature on this little chart down here.
So mine's just fake, or what?
And in this case, we've chosen 20 degrees. And I like to draw a vertical line the whole way up. Now, second thing you need to do is calculate your pressure height, and you're going to do that from the figures that they give you. And in this case, we've calculated it out at about 3,000 or just over 3,000 feet in pressure height. Now, the other thing before we go off and we work out exactly what our takeoff distance required or available is, we also need to go, okay, are we within the climb limitations of the aircraft? Now, you'll note here that they've got 4,000 feet, 5,000 feet pressure altitude and 6,000 feet pressure altitude. So in other words, what they're telling us is, way down below 4,000 feet, this isn't going to be a limiting factor on this chart. So they're only really concerned when you're up around this range. And all you do is you come in on the temperature, which you've drawn all the way up from the bottom. And if our pressure altitude was at 5,000 feet, then our climb limitation weight would be right there at about 1060 kilos. If our pressure altitude was, say, 5,500 feet, which is roughly about there, our climb limitation would be about 1,015 or 14. Now, you do need to be deadly accurate on these CASA. Wants you to be deadly accurate. And that one there, see how I'm not quite in the middle? That wouldn't be accurate enough, right? So quite in the middle, that wants you to be deadly accurate. And that one there, see how I'm not quite in the middle? That wouldn't be accurate enough. You to be 1,015 or 14. Now, you do need to be deadly accurate on these CASA. Wants you 14, about 1,015 or 14. Now, you do need to be deadly accurate on these CASA.
But how can you get 1014 from here? It could just be 1016, 17, 18. How can you go down to the correct single digit from a drawing that is this unorganized?
Wants you to be deadly accurate. And that one there, see how I'm not quite in the middle? That wouldn't be accurate enough, right? So I don't know of any CASA questions that are asking about this part of the chart. So let's move on to the other part of the chart. Now, what we do is we come in at our temperature, and then when we come up to our pressure height that we've calculated, and we go straight across to the start of this box. Now, you notice that each of these boxes, so there's surface, slope, ambient wind component, and the takeoff weight, these first three all have what we call a reference line. So what you're going to do, excuse me, is you're going to come in and you're going to stop at the reference line. And then you're going to go from the reference line to the condition that applies. So in this particular case, you can see we came in, we stopped at the reference line, and then we followed the shape of these predetermined curves that they've given to guide us, these dark lines, and we've gone up until we've met short dry grass line. So in this case, we have short dry grass. And then we go across and we exit that box and we keep coming.
I don't understand this. Like, obviously my textbook is it's saying something completely different. So I don't even know what am I supposed to do here. I don't understand why I'm wrong. Like, I'm obviously not right, but I don't understand why I'm wrong. Please tell me, why does he go in at 30 degrees when the question literally says 10 degrees? Why do you do this kind of bullshit? And it's so stupid. And you don't say anything about it. And maybe the second one is better. What? Oh, wait. Oh, you fucking... You're supposed to... So this is the degree line. I see. So it's not here. Did you go all the way through? So you follow this line here. So... Can you please not do it for me so I can at least do something myself? Oh, you fuck. Alright, so you go from here. Climb weight limit, because this is sea level. And everything is always standardized for sea level. So where this intersects here, you have to go over. Now, from here, you go straight up. Now, okay, what I don't understand is... Okay. And then you go up to... where the 900 meets. It is here. Now, what I don't understand is... Why? How can you, from this drawing now, okay? How can you say this is 10,080? Sorry, 1,080. Here, look. Wait, what? Here. This gives us a climb weight limit of 1,080. How can you say that this line here is 1,080? It's so inaccurate. It could be anything. I'm okay. It's above halfway point, so it's above 10,075. Sorry, 1,075. But how do you know it's 1,080 and not 1,078 or 1,082? How do you know? How are you supposed to know? Because the scale is not small enough to be accurate enough. Right? Like, what do you do? Scale to what? Well, you see here, it's 50 per box. So from 1050, one box is 1100. Which means this one here is above 1075 because it's above the middle point. But how do you know the exact number? Like, how can they just say 1080? If you're directly on the box, okay, yeah, 1050. All right, I get it. But if you're here, how could it not just be 1080, 82, or 1081, or 1078? I suppose it's round? Because the guy in the video just said you have to be absolutely on point with it. What do you mean convert it to mm or cm and do it? Convert what to mm or cm? You mean the box? You mean you convert everything into a smaller scale? But how would you even do that? Because then the line is also not accurate anymore. Because the entire thing would have to be scaled down, no? And they didn't tell you. Yeah, but they didn't tell you anything about this. Like, if they wanted to do that, they should tell you, no? My guess is that they just rounded it to 1080. Like, if they, because it's a textbook, right? It's a textbook that's supposed to teach you the usage of these things. If the usage of these things needs the usage of making the box scale better, so you can actually read the exact value, they need to tell you these things. Because even the other guy, like, that does videos on this, he did not do that either. But he said the value is super important. Like, okay, let's just go back here. Okay, I don't even know how he said this. Maybe you understand. Yeah.
Right, and that one there, see how I'm not quite in the middle? There's Casa.
All right, here. All right, listen to this part. All right, listen to this part.
Wants you to be deadly accurate, and that one there, see how I'm not quite in the middle? That wouldn't be accurate enough.
So, wait.
You
All right, here. Now listen.
do need to be deadly accurate on these Casa, 13 or 14, about 1015 or 14.
Here, how do you say this? 1015 or 14? You need to be deadly accurate. How can you be deadly accurate if you have a scale like this? It's a scale that runs by 10, right? 10, 10, 10. So if you're at the upper limit of, let's say, 1010, like you're a bit below 1010. Yeah, it could be 1011, it could be 1012, it could be 1013. How are you deadly accurate? You cannot be deadly accurate with these kind of charts. It's not possible.
You do need to be deadly accurate on these Casa. Wants you to be deadly accurate, and that
He says he wants you to be deadly accurate, but then he says, I'm not quite in the middle here. Like, what does quite in the middle mean? In the middle of what?
one there, see how I'm not quite in the middle? That wouldn't be
What do you mean by in the middle?
accurate enough.
What I don't understand to begin with, why is there a line here? This one I understand because it intersects. This one I understand because it intersects. But why is there one here? There's no intersection at all. He just drew a line. And he says he's not accurate enough. Of course you're not accurate because you're just drawing a line, bro. Like a random line. That line has no purpose. At least to me. I can't find a purpose. Even this line I also don't understand. Isn't the intersection here? Why is it so far down? Now I'm serious. Like I'm actually trying to learn this. Can like somebody sort of figure out why? Like the line here is too far down, and why is this line here? Or am I stupid?
Right. So I don't know of any CASA questions that are asking about this part of our temperature. I mean, and then when we come up to our pressure height that we've calculated, and we go straight across to the
Oh crap! Sorry, I forgot I had the other thing on top.
I don't know of any CASA questions that are asking about this part of the chart. So let's move on to the other part of the chart. Now, what we do is this part of the chart.
What I'm asking is, why is there the middle red line? And why is the bottom red line not on the black line? Because that's where they intersect. In theory. There's no line there. There shouldn't be any line there.
So let's move on to the other part of the chart. Now, what we do is we come.
The red line in the middle. Like this one. The one in the middle. Why is this one here?
Part of the chart. So let's move on to the other part of the chart. Now, what we do is we come in at our temperature, and then when we come up to our pressure height that we've calculated, we go straight across to the start of this box.
See, that's also what I don't understand. We calculated our altitude. Okay, so this entire line here from 2000 to 4000. Okay, you have like a couple more boxes here. Okay, how many boxes do you have? Let's do the math here. So from, let's just say, this box to this box, it is 1, 2, 3, 4, 5. So roughly 400 altitude per box. How can you say I calculated this and then just put a random ass like, dude, it's a 400. It's a 400 measure. How can you be deadly accurate on a 400 measure? You know what I mean, right? Like, you can't just make your own chart because this is the official chart that you're supposed to use, right? This is the official chart to show you, do you have enough distance or not? You can't just make your own and say, yeah, here. So you have to do it on this one. How can you be accurate when a scale is running on 400s? Because every box, from what I can see anyway, is roughly 400. One, two, three, four, 5 boxes. That is impossible.
Our pressure height that we've calculated, and we go straight across to the start of this box. Now you notice that each of these boxes are referenced from the curves that they've given to guide us.
Anyway, I understood now how they did it, but I don't understand how you can be so accurate with the limited information that you have. The software you will use, the software you use is, at least that's what everybody says, you have to draw it on paper yourself with a pencil and the ruler. So you don't actually use a computer for this. I mean, I hope notes work in terms of accuracy. I really hope they do. Yeah, but if the notes are exact, but your drawing isn't exact, for example, like, what will they do? You know? So then from here, we have to intersect this line. No, you're straight. You have to be completely straight, okay? Done. Stop moving. So I'm not a paint master. I usually never use paint. Boom. Okay, then from here, we have to intersect this line. And then again, how can you be deadly accurate here with this sort of angle of the line? By right, you have to calculate the angle of the line first, no? Or I guess you could put your ruler here, and you can just drag your ruler a bit further down. And I should also do the trick. Probably. So what you could do is, you draw like a straight line from here. Here-ish. And then you can connect the lines. No. From here-ish. Then you can connect these lines. And from there you can just do a straight line down. I think that's what I would do probably. And you stop roughly here. And then you have to go to your slope, to the degree of your slope. which is 2. Boom. And then you have to go down to the crosswind, which in this exercise, or in this case, the wind is 0. So you just go, oh, whoopsie. Just go all the way down to... that would probably be too inaccurate already. So you just take here. You go down all the way to 0. Boom. And then where they intersect, you go all the way to the left and you have your weight. Now again, so to me it looks like, I'll just say approximately, okay? Approximately. It's like 115, okay? I don't know the actual number, I'll just say 115. Or it is 115. Okay, how convenient. But what if they said 117? I don't know. What was the question here even? Determine the maximum permissible takeoff weight for following conditions. Okay. Now let's do that again on the same graph. Okay, but for the next condition. So we have like a rough... Now that you did it once, it's really easy. That's the thing with these graphs, right? Like once you did it a single time, they're very simple to work with. It's just the first time that's hard. Okay, so 4,000 at 25 degrees. 25 degrees. Now, how do you do this accurately? How do you draw 25 degrees accurately? I assume just here in the middle. You have to go all the way. Okay. So we do 4,000. Start here, we have to go... Oh no, wrong. Need to get a small pencil. So we go 4,000. Ah, crap, dude. 4,000. Why am I still drawing? Line. I have 4,000. I pull a line to... Yeah. 25, roughly. Yeah, this should be somewhat... This is 20, this is 30, somewhere in the middle. Okay, approximately. Okay. Then enter 4,000 feet. Yeah. What else do we have? Calculate the takeoff distance given... Okay, and from here, we go all the way up until the climb weight limit, okay? Boom. And we go all the way up. Until, I mean, we just keep going up, basically. Up. Oh, well, I don't know how far. So I'm just gonna stop here for now. Boom. Boom. And then where this blue line intersects, so roughly here, that's where we put... Boom. Okay. So I'm just gonna say, see, it's not exactly 1,050 in my drawing, but I'm just gonna say 1,050. That sounds about right? Yeah, 1,050. Draw a vertical line. The takeoff. Notice this takeoff Notice this takeoff has a climb weight limit. Project the horizontal line, which is therefore the takeoff weight. Because the answer of the question we must look at. Because to answer the question, we must look at the maximum possible takeoff weight. Okay. Oh, then you have to come from the other side. Okay, so if you're looking for the weight, you have to come. Okay. So now you have no wind. So you continue this line. Okay. So you continue this line to 0. Boom, that's here. And you continue to the slope, which is level 0. Okay, and from here we just go straight up to 0, which is here, straight. Okay, right up here. Boom. That looks pretty accurate. And from there we go left to long dry grass. So we go left, straight left until we hit the box. Boom, we hit the box here. Then we need to go follow the same line that this gives you. So long dry is this one. Oh, sorry, I have to actually continue until wait, what do I do now? I have to draw a line here that goes in this line until I hit that line. But at what angle? At a steep angle, right? I mean, the best way to do that for me would be here. No. Bro. You have to go up. Up until you hit this. I have no idea if what I'm doing is correct at all right now. Then okay. So you also have to make this line up. And then if you go straight here, the line will intersect at like 1,100. 1,140 in this case. Not sure where went wrong. Ah. Oh, okay, that's where I went wrong. So when you work backwards, you have to go here all the way through, and then you take. Oh yeah. And then you take the lane from here to there. Okay, anybody that's good with drawing, what's the easiest way for me to get the angle here correct? Other than calculating it. Like, how can you... And of course, I don't have a ruler here, so I can't measure it. From like from this perspective that I have right now, what's the easiest way to get the correct angle here? Something like that. Deeper than that. Like this. Something like that. Boom. Then if you draw all the way over. That's too steep. I'm not sure how you follow this like accurately. Hmm. Any function here that does it for you? No. From here. But again, I don't understand how you get 1,140 from that. How do you get 1,140 from that? I wonder what sort of margin you have there. I am pursuing aviation pretty seriously. Thanks, man. Yeah, I've been tryharding. So, in fact, I know it's very short notice, but I'm leaving in 6 days. Or planning to leave in 6 days to get my license. My recreational pilot license. And I want to use that license to apply for a cadet program, which hopefully gives me an advantage in the selection. Oh, that's for the Piper. The other one for the Cessna. Bro. Different aircraft has different charts like this? That's crazy, bro. I'm probably still gonna try to stream in the evenings or something, just to give like some progress reports, and maybe during studies as well. Just to keep you guys updated, you know. Hopefully not. That would be very concerning. But you know what I don't understand, right? I need somebody smart, okay, to tell me right now. Like, how do you get these angles? What angle do you follow on the surface? Wait. No. Am I that dumb? Wait, no, no, no. No, 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 no. Yeah, I'm not that dumb. No, I'm not that dumb. Yeah. how did you know what sort of angles you have to go at from this? Like, it's easy if it's a straight line. But how do you know what angles there are? Or you're supposed to go with? Like, for example, here. And how do you know this is the correct angle? Because it doesn't look like any of the other angles. Right? Like, this one here. Or this one. Or this one. How do you know? This line looks incredibly wrong. I don't know why. Okay. Put that in here. No, I don't think about reading it. Just tell me how to... Like, why did he draw the line like this? That's all I need to know. Okay, so basically, what you're supposed to do, you're supposed to reach from here to the line that says short, dry grass, okay, from here. Why is it at this angle and not just at this angle? Like, why do you have to follow this angle? How do you get this angle? And what is it? Because it looks so different from the other angles. Look at this. Not at all are the other ones this steep. Yeah, just tell me what the angle is. Then I can tell you the rest.
Throttle prior to brake release and on a paved level dry runway with zero wind. So if you put your flaps differently, if you don't apply brakes before throttling up and let the engine spool up to full power and everything, then these figures wouldn't exactly be accurate as indicated. And to clear, avoid taking off with the tailwind then, because just 2 knots of tailwind means these distances go up by 10%. Well, then we could decrease these numbers by 10%. So that would take into account 5, 50% longer than that.
The angle between this line here and this line. You can see it, right? These two. Yeah. This brown line and this brown line. Like, why is it going up like this? How does he do this? For an example, right? Like, why is it up like this? And why isn't it just up like this? Or straight line? And where do you get the angle from?
The next thing about these charts is we have these things called little reference lines, and they kind of trend in these different curves, and the purpose of these is for us to follow them when we're making our calculations. I'm going to explain that here in a sec. So if you happen to actually intersect one of these lines, you could follow it on up or follow it on down, but if you're in between them, you'll just follow the general trend. So if we come over here and intersect right here, and we're going to 2,600 pounds, we would follow the trend lines down to where 2,600 pounds meet the roughly where that trend would be, and then proceed straight across. So let's go ahead and work through an example here. Our example today is going to be that it's 20 degrees outside air temperature.
So he literally just said it. It's a rough guideline. Okay, it's a rough guideline. So that's all it is. All right. Okay. Okay. It's a rough guideline. So I don't know why this looks completely wrong. It's not even round or anything. It's just actually, this looks terrible. Another terrible example. All right. Let me see. I have landing charts after that as well. Okay, well, let's just take this one then, since we don't have anything else. Okay, so, I mean, this chart is really easy. Like, all these charts are really easy. I just don't understand the angles. I mean, I understand the angles, but it's just... I'm terrible at drawing. Anybody that followed me for a while knows this. I'm awful at drawing, so making me draw things is GG. Okay, here. We start at 16 degrees, okay? It says here. I don't know if you can read it. Wait, let me move that a bit. Alright, let me move that here. Okay, yeah. It says 16 degrees, okay? So we move this down. And we start at 16 degrees. But the problem is, they already did everything for me. So I don't even need to think, which is very annoying. I'm just kind of going through it to get an example. Okay, so sides, we go super small. Because you have to be deadly accurate. Now, how are you deadly accurate at 16? This is easy here because it's 3 boxes. So 3 boxes is easy. And then our altitude is 6,000 feet. Our pressure altitude, which is here. Okay, so we go from 16, and we go all the way. Oh, fuck me. I went for drawing again. Line. Okay, we start here, and we go all the way up where we meet 6K. So roughly here. Okay, we're already as straight as possible. Boom. Then the climb weight limit at 6K would be here. So you just go all the way up again to get your... Oh, fuck. To get your max climb weight limit. Alright, we're somewhat straight here. Yeah, we're pretty straight. Boom. And just follow straight left from here. Boom. And this would be roughly 1010. Okay, roughly 1010. Now, what do we have next? Next, we got short, dry grass, the surface. Okay, short, dry grass. That means from here, roughly here, we have to go all the way over to this box, to the intersection here. And from this intersection, we have to see where's short, dry grass. Here. It's short, dry grass, right? Is here. At this line. So we just go up. I don't know at which angle. That's my problem, as I said. So you just kind of spitball it. You kind of go the same way. It would be somewhere like here. Could also be wrong. Who knows? Or the examiners will let you know. And from here, you go all the way right until you meet the what's the slope? 2% down slope. The 2% down slope is... Oh no, you have to reach the next reference line, sorry. So from here, we go to the next reference line, which is always the thick blue lines. Okay. Boom. And from here, we have to go to 2% slope. Was it up or down? 2% down. So 2% down is here, this line. And from here, you just kind of follow again. I don't know how accurate you have to be here, but you kind of follow it down to here. Boom. And from here you go straight again all the way until the next reference line. It's actually really simple. You just have to be like straight. And then wind, we have condition 10 knots headwind. So headwind is here. So the reference line for 10 head is here. 10 head is here. What would happen if it was tailwind? You have to like draw it back up or what? Because tailwind is here. You have to like draw it back up and then go. Okay. So 10 head is here. And then you draw roughly in the same direction again until it meets. Boom, here it meets. Then lastly, we had 850 meters. Now, 850 meters. Whoops. 850 meters. Which I don't see because I didn't take a proper picture of my thing. Okay, so 850 meters would be the third. No. Takeoff distance available. What is this down there? Oh, takeoff weight. Oh, my bad. And they're looking for, what was the question again? They're looking for determine maximum permissible takeoff weight. Okay. So you have to find 850. This is 800. Boom. So this would be 800 here. But because it's 850, you have to draw. So this would be 900. No, this is 900. So you have to kind of go in between the two lines. And if you then draw a line up roughly up here. Boom. Like that. Okay, so we're going to be roughly here. And a straight line connects from here to here. It's connected like that. Boom. And from here, you just go straight down. And you got your weight. Which again, I don't know how accurate it needs to be. But this one is actually like decently accurate, I think. So this one would be... it's 1, 2, 3, 4, 5. 5 and a bit. So 950 is 5. It's past 950. So this is 1, 2, 3, 4, 5. So this is 10. So it's roughly 960. Roughly 960. From this point, is the climb weight limit. The maximum permissible takeoff weight on this runway in the given condition is 960 kg. Okay, can you? I need another smart person here. Okay, you said you're an engineer, right? You must be smart. Here, this it asks for determine the maximum permissible takeoff weight. Right? Now, if we go back here, the maximum permissible takeoff weight is here, right? So once you have this number, why do they say you still need to calculate this? Isn't it weird? Because the question is this. Why do you do this as well? Any smart person here that can answer this question? Is it just to like double check or what? Because by right, it's useless. Hmm. Okay. Okay. Done that. Done that. So let's say we calculated pressure altitude, okay? Pressure altitude calculation. Boom. ISA 1013 HPA QNH 1020 HPA pressure altitude equals 1013 HPA minus 1020 HPA equals minus 7 HPA. 1 HPA equals 30 feet minus 7 HPA equals minus 210 feet. Pressure altitude at elevation. Elevation of 1800 QNH 1030. Okay. Then it's pressure altitude equals uh 1800 minus 1013 HPA minus 1030 HPA equals 1800 minus 17 HPA. 1 HPA equals 30 feet. 1800 minus 210. No. What did I just say? It's 510. Equals 1290. Okay. But then, if it was positive, you would do 1800 the plus is a plus. Yeah. Then if it's below altitude pressure, a standard altitude pressure of 1013, then you plus. Got it. Dude, I learned everything in inches of mercury. I'm very confused what this all means. To be entirely honest. I learned everything in American units. Okay, calculator. Pressure, altitude, QNH, 998. 1013 minus 998 equals 15 HPA. And aerodrome elevation equals 5050. So 5050 plus 450 equals 5500 feet. Pressure, altitude. Okay, then we have to go down again for the landing chart. And so this is a Cessna landing chart. Okay. Yeah. So same as before. So Cessna looks like this and Piper looks like this. All right. Color. So different airplanes just have different charts. And it's also pretty fucky. So temperature. I mean, I'm just gonna take a screenshot again and do it. Isn't really any better way of learning, I think. Boom. Boom. Into Paint we go. I want to make a new file first. Don't say boom. New. Okay, boom. Here we go. So what values do we have? We have 5,500. Enter at 5,500 at 0 degrees temperature. 0 degrees. 0 degrees goes here. Okay, so 5,500. Roughly half between this, so like 75%. Sounds about right. Here, small, okay. I think you can always zoom in to make it a bit more accurate. Probably good on the PC. And you probably don't want to have a black line. Let's choose red again. Okay. So we have this at 0 degrees. Then we have an LDA of 500 meters. Landing distance. Oh, okay. That's how you measure a go around. Okay. So you keep going all the way straight. All the way straight. All the way. Okay. It's not that easy when you zoom in. You go all the way straight until you meet the climb weight limit line. Okay. Which is here. Because this is the altitude. And you could also just do a different line here again. You don't have to go all the way through, actually. Because it's the same values. So this is 1080, which is the max. Okay, so 1080 is the max. And once you intersect this line here, and from here you go down. And then you have roughly... What is this? 1000. This is like 1020. Roughly. Okay, good. Roughly 1020. That's good. Then you go up here to landing distance required. So we have landing distance available of 500 meters. Ah, so you just completely disregard this part, and then you come in here again with your wind component. We have 6 knots headwind. 6 knots headwind is where do we start? Yeah, a little bit above the middle. It looks about right. I would go even a bit further. I would like start here somewhere. And then you meet the slope, which in this case is 2% up. Yeah. Which makes landing faster and increases the landing performance. And from here, you take a straight line left. From here, take a straight line left until what do we have? We have landing distance available, 500 meters. I'm a bit confused with that one. Ah, okay, you just intercept your original vertical line. Alright, that's easy then. So the original vertical line just goes up all the way. Boom, however long, just make it like super long. Like boom, right here, bam. And then the straight line here just follows this straight line where they intersect is the distance. And they intersect right at 480. Lucky you. Imagine if it intersected like here. Then you would have to say 477 meters. Am I studying for? Yeah, pilot license. I'm going to Australia in 6 days. Hopefully. I'm trying to plan everything right now. Alright, that's that. Okay, then we have another one. The Piper landing chart. Which seems much easier. Than the other one. But we'll see. That might be looks can be deceiving, my friends. But I'm sure these huge ass spiders are not everywhere, hopefully. I mean, you know what would be funny? Like if I come back and I'm like, I'm not afraid of spiders anymore at all. In fact, I became a spider. I became Spider-Man. Hell yeah. What about that, huh? Didn't think about that, did you? So we started 4,000 feet, 14 degrees Celsius. Okay, 4,000 feet, 14 degrees Celsius. Okay, we zoom in again. Maybe not that much. Zoom in again. Mark this, red. Size is small, good. So 14 degrees is exactly here at 2 boxes. We go up until we meet 4,000. I said this. To 4,000. Boom. And from there, we have slope of 4% up. Slope of 4% up. So we have to go to the reference line first. Always go to reference lines first. Always go to reference lines first. Boom. Then you follow. We have what? 4 degrees up, right? Yeah, 4 degrees up. So you kind of follow the same line-ish, which would be roughly about here-ish, until you hit the 4-degree line. And then from there, you have the wind component, 10% knots, or 10 knots headwind, 10 head. So you go to reference line again, reference line, Then you go to 10 head, roughly around the same here. And 10 head is there. So you go down here, 10 head, boom. And then from 10 head, you draw a vertical line to the right, and you're done. So the landing distance required is roughly 510 meters. So what does this mean? How would you do this? Should at least explain it to me, bro. Climb, weight limit, Piper landing chart.
Hey guys, what's going on? 1100, 1200 Celsius, about 32 Fahrenheit. We're going to come up to subscribe to our YouTube channel to take off. So it's
Oh my gosh, dude. Okay, guys, I need your brain power now. How would we use this? Just a straight line over or what? Why is it so uninformative? Like, just tell me how to calculate it, bro. In this case, you would use the small graph in the top left-hand corner of the main graph. Yeah, but how do I use it? Straight line over? Or where it meets, like this? Or I mean, I would love to learn about it, but there's no information. I'm actually starting to get triggered by the lack of information. The practice, whatever, dude. What is the sea level temperature and pressure? 1013 hectopascal and 15 degrees Celsius. What would ISA plus 15 mean? 30 degrees. What is meant by QNH? The pressure at the aerodrome or the particular level of elevation. What is actually meant by QNH? Mean sea level pressure. QNH is the current pressure, not the standard pressure at a set airspace. Density altitude is not a simple measure of height. What extra parameter does it account for? What extra parameter does it account for? Huh? It is a measure of height. What is the temperature? What are these questions, dude? The questions are killing me today. What extra parameter does density altitude include? I don't know. Humidity, temperature. Not sure what they want here. Stall speed, normal operating speed, never exceed speed, and flaps. A flap operation speed, I think it was. VE. VE. Wait, no, I have it in my list. VFE flex. Oh, flex extended. VFO was flaps moving. Okay, so VE. A VFE is flaps extended max speed. What is meant by takeoff distance required and takeoff distance available? But here it says takeoff safety speed. List 6 factors which affect the takeoff performance. 3 favorable, 3 unfavorable. Favorable. Low altitude pressure. Low altitude pressure. Downslope. And headwind. 3 unfavorable. Tailwind. Upslope. High altitude pressure. What is aquaplaning when the wheel can't grip to the ground? There's no traction. There's 3 factors which adversely affect landing performance. Downslope on the runway. A wet runway. And a heavier aircraft. Given the pressure altitude of aerodrome 2,500 feet and a temperature of 30 degrees Celsius, what would be the density altitude? Okay. So per degree, it is 120. 1 degree Celsius equals 100 feet. 15 degrees equals 1500 feet. Elevation 2500. So pressure altitude equals 2500 plus 1000. Is it plus or minus? So a higher temperature means it's lower. So it is 700 minus 1500. I think. Ah, if it's hotter, it's lower. If it's colder, it's higher. Because the higher you go, the more temperature decreases. So logically, if temperature increases, the altitude pressure is lower. Yeah. Oh, is it? Is pressure altitude higher if the temperature is higher than standard? I see. Now I've gotten into the space in my own head where I studied so much that something so easy is causing me trouble. You know, I've literally done this every day. So it shouldn't cause me any problem. So, what was the question even? Oh, the density altitude, not the pressure altitude. The pressure altitude would be lower, but the density altitude would be higher. So you have to add 3,600 feet. 1 degree Celsius is 100. No, 15. 15. So 15 is 1800. 1800 feet. So it is 2800 plus 1800. So we're looking at a density altitude of 4800. 4300, sorry. I think this looks about correct. Is that correct? I think it's correct. What effect would this have on the takeoff performance of your aircraft? Wait. You seem to know a thing or two. Just to sort of quickly summarize. High temperature means low atmospheric pressure or lower, but higher density altitude. Correct? Is that right? Bro. Now I'm like in my own head so much. Okay. Just read it again real quick. Okay, yeah. So what's the difference between the two? What is the difference between pressure altitude and density altitude? Oh, why did I think they were different things? So density altitude is just pressure altitude, but corrected for temperature. Okay. Okay. So the density altitude here would in that case be if temperature increases, density altitude also increases. Okay. So hotter, higher, colder, lower. But higher pressure means lower altitude. And lower pressure means higher altitude. Okay, now I got it. It took a while. Pressure, altitude, oh no, density, altitude is pressure, altitude corrected for temperature. Higher pressure equals lower density altitude. Lower pressure equals higher pressure altitude. 1 HPA equals 30 feet. 1 degree Celsius equals 120 degrees. So, okay. Okay. Man, that was way harder than it should have been. Okay. Now we can continue. Introduction to navigation. Okay, I don't think that's actually part of my test, but no. Okay. I thought it's crashed. 16. Introduction to navigation. 12. Oh. Chapter 12. Boom. Okay. Bruh. The path the aircraft travels is called its track. The direction the nose is pointing is called its heading. bearing is the direction of from point A to point B. Variation east, magnetic least. Variation west, magnetic best. Uh-huh. Alright. Remembering right now. Okay. Why do you keep going back to 16? Oh, did I forget to turn the thing off? Oh, I think I forgot to turn it off. Oh, my bad. Navigation triangle. Calculate the heading and the wind speed and the ground speed. Using a flight computer, bro. The it says track is 270 and it says the track is known as 260. Okay. Damn, dude. Holy shit. Is it a flight computer? What do you mean by 8 left? How do you read the drift? I don't even know what a slide or flight computer is. not? UTC, Zulu, and GMT is all the same. Dude, there's a huge time change from +8 to 9:30. Nothing in between. Specified by latitude and longitude. Latitude is north and south. Latitude is west and east. Why 0.1? Why 14.5.11.1? 1 to 1 million chance. Mhm. After a flood, for instance, a driver might be a raging torrent. Damn. Yo, what's up? Yeah, nerding indeed, dude. Tough. Very tough. Wow, I forgot I had class today. No team games, man. They don't work. Impossible. Purchase. Hmm. check mine. No. Yo, what's up, my friend? Hope you're enjoying the new patch, man. While I'm torturing myself. We're learning today. Well, I'm going to Australia soon for my pilot license. So I'm studying for that. Heading is where the nose points, track is the actual path of the aircraft. What is the angular difference? I have no idea. Oh. The difference between headings, bearings, and courses. I mean, yeah. What's the difference in meaning between true airspeed and ground speed? Ground speed is true airspeed corrected with head or tailwind. What is the mathematical difference? Well, either faster or slower, depending on if they have a head or tailwind. What is the reference for magnetic track? I don't know what it means. Oh, magnetic north. Is that what I mean? What is the difference in reference between track magnetic and track true? True is true north. Magnetic is magnetic north. Angular difference is called variation. What is the angular difference between magnetic heading and compass heading called deviation? Variation east is added subtracted from true track to achieve magnetic track. East is least. So subtracted, I think. East is minus, west is plus. East variation or magnetic heading plus minus east variation equals true heading. Magnetic heading plus west variation equals true heading. What given heading with airspeed and track with ground speed? What's the third vector in the navigation triangle? The crosswind and wind speed. What is Zulu time? Same as UTC and GMT. What is UTC? Same as Zulu time. Universal coordinated time and Greenwich Mean Time and Zulu time all the same. What's the difference between the UTC and Australian EST? 10 hours. 10 hours, I think, or 11. Not sure. What is meant by the scale of a chart? So if the scale is 1 to a million, that means, for example, 1 centimeter is a million centimeters on that particular chart. Give 2 examples of defining position on the Earth: longitude and latitude. Any else? What is the World Aeronautical Chart? What scale does it use? 1 to 1 million. If VTC is a larger, smaller scale than a smaller scale, I think it's 1 to 500,000. And isogonal joints areas of equal magnetic something. Magnetic declination. The angle between true north and magnetic north. So that's the angle of variation. Magnetic variation for Melbourne. I have no idea. I probably also won't need to know that, hopefully. Anyway, I want to go pee real quick. Then I'm gonna have to head off soon. All right, gentlemen. Or practice exams. All on board during climate ascent. Save. B. D. B. D. B. D. D. A. B. B. C. Was it D? D. A. 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 the... I'll show all of them. B. A. I don't know. C or D? Wrong. Wrong. Correct. 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 6 is the wrong. 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 Eight is the wrong. Correct. Wrong. 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 Correct. Wrong. Wrong. Correct. Wrong. Correct. Or I guess I should just say what the letter actually is. A D D A B C B C A C C B A D B C B D C. It's a lot of wrongs, dude. E B D B C C D B C B C D D D D C A D C A C C C D C B C D C A. Did I miss one? A B D B C C D B C B C D D D C C A D C A D C C D C B C D C A. I'm wrong somewhere. Alright. So correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, let's see. What are the correct answers then? Correct answer is pilot when he is a sole pilot. Okay, no. D. I got that one right, I think. Yeah. D. Got that one right. A. Horizontal is meters. Yeah. Got that one right. 5 is B. that one right. This is where I started going wrong. D. I said D, but the reality is C. Navigation must be by visual reference to ground or water. 7. B. She has passed the general flying progress test. Okay. 8. Height above mean sea level. Yes. What did I say? At non-tower aerodrome, you should not continue an approach beyond the threshold. Proceeding light aeroplane using the same runway. A. Okay, got that right. Non-tower. This is no. You should. Yeah, got that right too. One item which must be included in passenger. 11. B. The use and adjustment of seat belts. Okay, yeah. Got that wrong because it sounded too simple with all the other ones. With regard to the rules of the air, which statement is correct and accurate overtake another? You have to give way to the glider. No. Oh. Okay, wrong. 13. On which of the following types of flying is passenger? Flying training given to a person. Okay. Also wrong. 14. What's A? Oh, so you don't even have to say that you received clearance. In the mean sea level pressure. Of the area. Yeah. The altimeter should read airfield elevation. Yeah. One of the basic rules following an engine failure. Always try to restart the engine. Never turn back to the runway. Oh. $18B. Yeah. Right. Right down symbol is use of hard surfaces only. Ah, the dumbbell actually means strength. Damn. Oh, have you heard, Deathlead? I'm leaving soon. Going to Australia for a month. Hopefully, if I can get that sorted. In Australia, my flight training. color of Afghaz is blue. Of the above, the four, the 5. No, it's impact eyes. And air filter, okay. 67. Very fully charged and system is working normally. Oops. My bad. The battery. Yeah. Did the alternator fail and the battery power be consumed? The fuel boost pump would still be available. Most of the engine instrument would still be would stop working now. Excessive priming of an engine can increase the risk of manifold fire during start. Yep. Allow the pressure inside the tank to equalize with the outside pressure. Okay. Low power setting with rich mixture. Okay, had that right. Set the altimeter to QNH instrument should read vertical distance above mean sea level. Had that wrong. The red radial line on the airspeed indicator never exceeds speed. Rotation emotional axis referred to as rolling. Got that right. Got stability right. Being the tendency to overbank the aircraft as the horizon is not always obvious. Okay. B. A blockage of the static system would likely be corrected by applying alternate static on. 20. During your takeoff roll, the airspeed increment is zero. You should abort takeoff. Yeah. They have the air and radio. Ground friendly. Okay. Yeah. See. If you encounter gusting wind in this circuit, what speed would you try to maintain on the final approach? C. Yep. After start of the engine, 30 seconds for the oil pressure to normalize. 25. While taxiing, you notice another aircraft is approaching you on the same taxiway from the opposite direction. Move to the right and stop if necessary. An aircraft will stall at the same speed as altitude increases. When considering hazards or wake turbulence, most severe when large airplane is at low speed during climbs or approaches. Yes. All of the above. Detonation occurs in. Oh, the charge explosion is just burning. Okay. 30. Although the master switches. How come I had so many wrong then? One, two. Okay, so I had actually way more right than I thought. Let's go again. 1. Alright. Alright, guys. I'm gonna head out now. Go prepare for my gym class. My second last before I head off, hopefully. Thanks for watching, guys. I'll catch you all soon. Have a good evening, everybody, and bye-bye. See you soon.